13, 14, and 15, solving a basic trigonometric equation involving tangent, cotangent, secant, or cosecant. So again, doing the same things we did on 10, 11, and 12. This time we're working with tangent, cotangent, secant, and cosecant, but solving our equation. So I'm going to subtract my 1. Tangent of x equals -1. I'm going to go back to my chart, which again I forgot to show you since we're on the same page, but in case you happen to look later at the thing, we need this chart where we can look up our tangent, cotangent, secant, and cosecant values. And so going back over here, we said tangent of x equals -1. So if I look that up in my chart, after I find my chart again here in my pile, tangent equal to -1 would be at 3 pi over 4 and 7 pi over 4. Now notice that those are again 180 degrees apart from each other. 3 pi over 4 is 135 degrees, 7 pi over 4 is 315 degrees, but on tangent and cotangent, that's pretty much always going to happen, is that these are 180 degrees apart because its period is only pi and not 2 pi. So these ones we're going to be able to combine into just the one answer, like the very first problem on the previous ones. And so in this one, we're just going to say 3 pi over 4 plus, and we're just going to use k pi instead of 2k pi and have to do 2 answers. And, of course, k is going to be an element of z. K is an integer, in other words, 1, 2, 3, 4. On the next one, if we solve that one, first of all, we're going to add our 1. And so we're going to have the square root of 3 cotangent of theta equals 1. We're going to divide that by the square root of 3. We have to rationalize our denominator. And so we get square root of 3 over 3. So we're looking for where the cotangent of theta is equal to square root of 3 over 3. I've got to find my table again. Keep losing it. Cotangent. Last column, square root of 3 over 3 is at pi over 3 and 4 pi over 3. So again, you can see that those two angles are 180 degrees apart, or just pi apart. And so I'm going to combine that into 1 using my first angle. I'm starting at pi over 3. I can go k pi, add 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, with k being an element of z. So almost always on tangent and cotangent, I'm going to have plus k pi instead of 2k pi, and I'm going to combine my 2 answers into 1. And number 15, this time we're doing a secant. Secant's normal period is 2 pi, just like sine and cosine. And so solving this, whoops, board wants to be difficult. We're going to have square root of 3 secant of x equals a positive 2. And so secant of x is going to equal 2 over the square root of 3. If I rationalize my denominator, secant of x is going to equal 2 square root of 3 over 3. And so if I look up my secant, under my secant column, 2 square root of 3 over 3 is at pi over 6. And then if I look for another 2 square root of 3 over 3, I am at 11 pi over 6. Again, these are not 180 degrees apart, so I'm going to have to use the 2k pi and put in 2 separate answers. So I'm going to have pi over 6 plus 2k pi, with k being an element of z, or 11 pi over 6 plus my 2k pi, with k being an element of z. So when those angles are not 180 degrees apart from each other, I'm going to use 2 answers with a period of 2 pi in order to get them all in there.